Sarve Jana Sukhna Bhavantu. Hi friends, this is your Dr. Bapuji Pullepu alias Dr. BP. See, in this program we discuss, in this video we discuss actually 3 eigenvalues repeated. Previous video I completed when the 2 eigenvalues are repeated. But previous of that video we done non-repeated 3 eigenvalues. So 3 by 3 matrix, 3 models. One is if it is not repeated, if it is 2 eigenvalues are repeated, if it is 3 eigenvalues repeated, how to attack. 2 eigenvalues we done nicely. Now 3 eigenvalues how we will do. Once if they given me, so this you can take A is equal to, then write characteristic equation, determinant of A minus lambda is equal to 0. This implies what is it? On diagonal you can give minus lambda, minus 6, 5, 14, minus 13, minus lambda, 10, 7, minus 6, 4, minus lambda. So this is will become lambda cube minus s square lambda, s1 lambda square, s2 lambda minus s3 is equal to 0. Now who is s1? Sum of the diagonal elements are trace. That is equal to what? 6 minus 13 plus 4. 10 minus 13 minus 3. S1 is minus 3. S2 is equal to what? Cofactors of diagonal elements. Who is cofactors here? Cofactor of 6 is what? Determinant of, leave this row, this column, this row. So what you will get? Minus 13, 10, minus 6, 4. Plus, so 13 means what? Leave this column, leave this row. So what you will get? 6, 5, 7, 4. Then plus, leave this row and this column. So what will get actually? 6 minus 6, 14 minus 13. Then if we simplify, what you will get actually? 14 13s. 14 13s means what? 40 plus 12. 40 plus 12, 52 minus 52 plus 60. Then 24 minus 35. 6 13s. 6 13s, 60 plus 18. 60 plus 18, 78. 6 14s. Already one formula in minus, here 1 minus, 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 plus. 60 plus 6 4s, 24. 60 plus 24, 84. So if we simplify, what you will get? S2 is equal to 3. You will get, just I am skipping, you can check actually. Then S3 is equal to a determinant of 6 minus 6, 5, 14 minus 13, 10, 7 minus 6, 4. That is equal to minus 1. Just I am skipping, you can do this. I am giving in your hand. Now S3, sorry. Everything available, then come back and write in this equation lambda cube. So what you will get? Shall above. Matrix I kept there. If I substitute in this equation, what you will get? Lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. So lambda cube plus 3 lambda square plus 3 lambda plus 1 is equal to 0 after substituting s1, s2, s3 values. Once if I get, I will do find out the rules. One root if I find out, I go for this second degree roots. Suppose put all are plus means I will start with minus value. Lambda is equal to minus 1 means what? Minus 1 plus 3 minus 3 plus 1 is equal to 0. So lambda is equal to minus 1 is 1 root. So this whole equation, how can I write? Lambda plus 1 into something. This something I want to find out. To find this something, I will use synthetic division. How you will go? Right, third degree coefficient is what? 1. Second degree coefficient 1. Then 3, Then this, if you seeing this, you can sell lambda plus 1 whole cube actually. Otherwise you can write 1 below 0, you can give minus 1, 1 plus 0, 1, 1 into minus 1, minus 1, 3 minus 1 is 2, 2 into minus 1 is minus 2, then 1, 1 into minus 1 is minus 1, 0. If you don't get 0 means what? This is not a root. That is a factor theorem or remainder theorem. So this how can I write? Lambda plus 1 into lambda square plus 2 lambda plus 1 is equal to 0. Now this fellow is what? Lambda plus 1 into lambda plus 1 whole square is equal to 0. So lambda is equal to minus 1, minus 1, minus 1. 3 times same repeated, very dangerous. Already I told you to find eigenvalues. If any two roots are repeated means what? All equations are same. You will get all equations same means you are not able to solve. Put x1, k1, k2 like this you can find. Otherwise, if you have 3 different equations I can able to attack. But if you don't have means what? You have to solve actually. Non-trivial you have to find. Trivial anyone we can do. x1 is equal to 0, x2 is equal to 0, x3 is equal to 0. Anyone can tell. But I need non-trivial solutions. They will have infinite number of solutions. Try to find out one solution. Okay. Keeping this, now I will go for to find eigenvectors. To find eigenvectors, what you will do? To find eigenvectors, what you will do? Matrices of A minus lambda into this is x. To find eigenvalues, this is determinant value, but this is matrices value. So carefully you can write. On diagonal you can write 6 minus lambda minus 6, 5, 14, minus 13, 10, 7, minus 6, 4 minus lambda, x1, x2, x3 is equal to 0. Now write. When lambda is equal to minus 1, only one chance only. No need to find 3 roots. All roots are same. Only one time I will find out. Then what you will write? When lambda is equal to minus 1, if you substitute 6 minus half minus 1, 7. If lambda is equal to minus 1, 7 minus 6, 5. Then 14 minus 13 plus 11, minus 13 plus 1, 12, minus 12, sorry, then 10, 7, minus 6, 4 plus 1, 5. You see how nicely? Only one fellow only, multiply by this fellow 2, you will get the same fellow appearing 3 times actually. 3 positions is standing, x1, x2, x3, 0. So if you write, what you will get? 7x1 minus 6x2 plus 5x3 is equal to 0. 14x1 minus 12x2 plus 10x3 is equal to 0. 7x1 minus 6x2 plus 5x3 is equal to 0. Now write. Because 3 different roots means I can tell x1, x2, x3. I can't because only one equation is there. You will have an infinite number of solutions. In that one solution I want. So I will use parameter. x1 is equal to something or x2 is equal to something. 2 roots means what I told. x2 is equal to k1, x3 is equal to k2. Put k1 is equal to 0 and k2 is equal to 1. Then k2 is equal to 0, k1 is equal to 1. We done nicely. But this already there I told actually. For third case is what? The first one I want to make 0. Such a way I will try. Okay, don't confuse. I will do, no problem. So taking one equation. Taking first equation, how can I write? 7x1 minus 6x2 plus 5x3. So this how can I write? 7x1 is equal to 6x2 plus minus 5x3. So x1 is equal to 6 by 7 x2 minus 5 by 7 x3. Put x2 is equal to k1 x3 is equal to k2. Then x1 will become 6 by 7 k1 minus 5 by 7 k2. Okay or not? Now what is my x? 6 by 7 k1, 5 by 7 k2, k1, k2. This already, if I give an equation 1 means you can go 2. Into 3 cases I want to find out. Now first case and second case already I know. For 2 repeated roots I done. For third case only here new one. So first case 1 is what? Put k1 is equal to 0, k2 is equal to 1. Some people they will write some division also, some 7 or like, I don't want to. Just 1 0 I will find out. I will tell you how to do. So x1 is equal to what I will get? k1 is equal to 0 means 5 by 7, 0, 1. So then multiply by 7. So this is equal to approximately what? Minus 5, 0, 7. Some people they will confuse, take 1 by 7 like this. No need, not required. 7 by 1 I don't want. Take 1 and 0 only. Case 2 is what? Put k1 is equal to 1, k2 is equal to 0. So x2 become what? k1 is equal to 1 means what? 6 by 7. Then 1, 0. Then this if you multiply by 7 means what you will get? 6, 7, 0. Now case 3 only will speak slot. Case 3 how you will do? Case 3 such a way you can do, this term you can make 0. Such a way you can give k1 k value. What values if I give k1 k2, this whole thing will become 0. First 2 cases, this is 1, this is 0, this is 1, 0 I got nicely. But third case 3 are repeated means what? The first fellow also you can make 0. Such a way you can choose k1 k2 values. Previously 1 0 we played nicely, but here we will change. 1 is plus 1 means what can I take here? K1 is 5, k2 is equal to 6. Job is over. Correct or not? Somebody else 7 by 5 don't want this. Don't take fractions. Simple numbers I will take. I will tell you. Now what I will take? K1 is equal to what? I will take here 5. Here I take 6. 6 into 5, 30 by 7. 5 into 6, 30 by 7. So put K1 is equal to what? 5. K2 is equal to what? K2 is equal to what? 6. Then first below become what? 0. Then K1 is what? 5, 6. So eigenvalues are what? Minus 507, 670, 05. Then write eigenvalues are minus 507, 670, then and 056. So this is the case of 3 repeated. You don't worry. Actually, next they will do similar symmetric matrix. I don't want to do symmetric matrix. This is also same story. When I am doing the orthonormal transformation, that time I will take. I don't want to do again. I don't want to confuse. I will stop here to find eigenvalues, eigenvectors. This is enough. Next video we are going to do the properties of eigenvalues. Then later I will go Cayley Hamilton there. After that we can go orthonormal transformation. Then lot of things are there, quadratic form, signature, radius, lot of things that we discuss later. Now I don't want to confuse now. Up to here clear? Okay, I hope you understand nicely. Kindly share and subscribe our channel. Be part of our service. Bye. Meet in next video.